Hello, I am Udita, and welcome back to Satisfactory. This is episode 16 of the load balance playthrough, and today I'm going to tackle everyone's favorite, aluminum. I've been using this temporary factory setup in the South Red Forest. If you'd like to see a video on my initial setup or how I use blueprints to build this simple but effective trade network, let me know in the comments. I have almost all the alternate recipes available to me. I'm going to utilize Sloppy Alumina, Electrode Aluminum Scrap, Pure Aluminum Ingot, and the heavy oil residue recipes. These are great alt recipes that give a better output of aluminum than the default recipes, as well as cut out silica from the whole process. I'm going to use all the bauxite in the swamp and turn it into 1500 aluminum ingots. I'll use some of that to make 60 a minute of each aluminum sheets and aluminum casings. The rest will then be used for future projects, much like I did with the plastic and rubber factories. I'm going to be using this spot and these nodes. Let me briefly explain what's going to be going on here. So in total, we're going to be bringing in 1500 bauxite. We'll need 450 water from water extractors. Those are going to make the sloppy alumina. The next step is the electrode aluminum scrap using that alumina solution, but it also needs petroleum coke. So to make that, we're going to utilize our new well pressurizers and the crude oil well that's over there in the corner. We're going to turn that into heavy oil residue and then into petroleum coke. The electrode aluminum scrap recipe has a large amount of water as a byproduct. We're going to use that and recycle it back into the first step. It also outputs 3000 aluminum scrap. We're going to use the pure aluminum ingot recipe to cut out silica completely. 50 smelters will turn that into 1500 aluminum ingots. Let me run through the blueprints I'm going to be using. I need 10 refineries doing the sloppy alumina recipe, so I'll need 5 in total of this blueprint. Each one is going to be clocked at 75% so that the output is exactly what the next refinery needs. And to explain the whole water situation, I realize this pipe may look a little bit silly, but for one, I actually kind of like the way that it looks. 2, it's extremely functional. So this pipe right here is going to be coming from the electrode aluminum scrap, and this is how we're going to recycle the water. So I have one valve here to make sure that there's no backflow so that that refinery can keep emptying its water. Now, the reason why we have this little bump in the pipe is when you have a pipeline junction cross vertical instead of completely horizontal, it's going to prioritize the horizontal pipe over the vertical input. So this way, it's going to prioritize the water that's being recycled, because if that refinery backs up, then everything kind of starts having issues. If the water extractor backs up for some reason, that's not a big deal, right? So I'd much rather have the water that's coming from the water extractor get a secondary priority, and I want the refineries to never stop running. So that's why I have this set up the way that I do. The water extractor is going to plug in right here. Each machine is in need of 150 water, and let me show you the next blueprint. So the refineries for the electrode aluminum scrap are in the same layout so that I'm able to just connect the pipes easily. This is where the recycled water is going to come out, and I just need to connect the 2 pipes. And this is going to output 105 water. So the first step needed 150. This gives it 105, meaning I'm short 45 water on each one. So since I have the way that I have the blueprint set up is that 2 of them are joined together. So in total, they'll need 90 water from each water extractor. And oddly enough, this process ends with smelters instead of starting with it, but I'll need 10 total of our 5 smelter blueprint. There aren't too many towers to build, but let me put those up and then we'll start placing all these machines. With the towers and platforms built, let me throw down all of these machines and then I'll talk my way through building it up. Okay, so now with all the machines in place, let's get it all belted and piped up. So we'll start with the water. So to kind of quickly go through it, the final output is 105. These need a 150. So since the way that I have it as two machines are piped up together, that leads us with 45 water per machine. So each of these water extractors are going to be clocked to 90. And all that's left is to connect all of the blueprints together. Alright, and we'll switch to white because these are outputting alumina solution at a rate of 180, and each of these refineries have an input of 180. So this is just a nice, easy, straight shot between all of these refineries. So as far as the inputs, each of these refineries need 150. So combine going into each of these splitters, we need 300. So, and that's what we're going to deal with. So we're actually going to go ahead and just belt these out from here. Okay, and that's how we'll be getting the bauxite and the water sorted. So really, all that's left is the petroleum coke, and then feeding the smelters all of the scrap. So let's go ahead and deal with that because that's right here. So each machine is going to put out 300. With an input of 60 aluminum scrap, that means 5 of these together needs 300. And since I'm going to go ahead and just group each pair of refineries together, I'm going to go ahead and just group each floor. So that means we're going to input 600. So this one actually is going to be the only one that's slightly offset. Makes more sense just to line it up with that splitter. So the rest of these floors will be right in the middle. So it means we just need to plug 600 up into each floor. And each floor will output 300 aluminum ingots. So since I saved the blueprints with all Mark 1 belts, I do need to remember to go back and change the speed of some of them. So in my opinion, whenever you're dealing with a system that has to loop back, so the initial amount is going to increase after a cycle or two, it's easiest just to work backwards. Since each one of these belts need to be a full 60 a minute, that means this belt needs to be 180. So we can go ahead and make both of those 180. All 3 of these need to be 60. So if this is 180 and 180, that means this needs to be 360. So we just go ahead and make that one a Mark 4. And so I just need to go ahead and make sure that I do that to each one of these sets so that the load balance works. And then as far as getting the scrap into here. I'm gonna go ahead and just belt it straight on over for this one. The rest of these, I'm gonna keep it the same height. I'm just gonna go ahead and throw in some conveyor walls, and we'll just feed it up the sides and then kind of bring them into the middle like I've done with a lot of the other builds. So let me show you the petroleum coke. Alright, so we're over by the crude oil node, which is a resource well, so you need the resource well pressurizer. So you do need to power them on to be able to connect all of the little satellite nodes to get the oil out of there. I'm going to go ahead and just do that later. Let me show you the pipe and belt work for the machines. So the first step is going to be making heavy oil residue, and these are all going to be clocked at 100%. So let's go ahead and just paint these our heavy oil residue color. And the next step will be the petroleum coke, which is going to have an input of the exact same amount of heavy oil residue that these are outputting. So we can paint these all black. So that does make the pipe work, thankfully, really easy, as I like to do in most of my builds. Keep it as simple as possible. The less junctions, the better, in my opinion. So if I can just connect one machine to the next with liquids, I just feel like it works better. Now we just have to deal with the polymer resin. So with the polymer resin, we're just going to sink it. Alright, and with each machine only outputting 20, we only need to mark 1 out of all of the refineries. We'll go ahead and set this one right here. So one of the nice things about finding just kind of like ideal spots, like where I put the refinery right on the split of 2 foundations, that meant that the pipes were going to run along basically this half of a foundation. The mergers and stuff just line up in these quarters, which is a really nice thing about the grip metal. And they always work in basically halves of foundations. So if I have one here, that means that if I place another one along this line right here in this half of the foundation, it's just going to automatically make a 90-degree angle. And that also means that the outgoing belt is going to travel along this one right here. So since each one of these is outputting at 20 and there's 5 machines, we've got 100 polymer resin going out of here, and we'll sink it. Cool, and then we just need to merge up all of these for the petroleum coke. So each one is outputting at 120. So out of the machines, mark 2 belts. But this has 240, so this needs to be Mark 3, and out of here is going to be Mark 5, because this is our 600 that we need for over there. So we just need to create a bus, and now we're back over here. So to do this, we've got 600, each machine needs 10. So we've already got them grouped up in pairs. So in my opinion, I'm obviously going to work with belts and adding some more splitters. It's easiest just to throw down some temporary foundations and just work on those instead of trying to nudge everything into the right spot. Since I don't like to do splitters right up next to each other, I usually do 1 or 2 back, and we'll just do 2 since I have the space. We need to do a 5-way split. There's 5 pairs of refineries. So we'll put one over here. So that will do with the last 2, or the first 2, depending on how you're looking at it. That'll go there. And then we need one right in the middle to go to both of those. So that one can be a nice right angle as close as possible. And let me grab some more cable. All right, get these recolored real quick. Okay, so we've got our 3 splitters, and the last part is the merger. So again, I don't like putting them right next to each other in case I need to change the speed, because I forget to put the right speed in all the time. It's just easier this way. So that should be all the ones that we need. So let's take a look and let's work backwards. So each machine needs 60, so we need 120 into each of these final splitters. So let's go ahead and do that. Nope, not that one. That one goes to here. Okay, and the way the 5-way split works is we have to split it 6 ways, and we loop back 1/6 back into the system. So this Mark II belt needs to feed back into that merger. Okay, so we've got all of our Mark II belts in. So into each of these splitters, that means we need 120, 120, 120, so that's 360. So we need a Mark IV belt into this splitter. And so if each of these need 360, that means this definitely has to be a Mark V. And we know that 600 is what's getting plugged into this whole thing. So actually it'll just be easier if... So I think what I'm going to do is we're just going to add one more row. Alright, so we'll run our Mark V out to here. And cool, I can reach. So then we'll just put a lift right here. Make sure it's facing the right direction. And that is how we are going to get the 600 petroleum coke into the refineries and load balanced. So the last little bit is this is going to put out 1500 aluminum ingots. What I'm going to do is sink the large majority of it, but I am going to use some of it. So each one of these is going to output 30. So we've got 150, which is exactly how much I need right here to turn that into 60 sheets and 60 casings. So what we're gonna do is we're just gonna send it this way, but I am gonna redo it. So since to make 60 sheets, you need 60 ingots. To make 60 casings, you need 90. So it's just a lot easier to get these merged up into the correct amounts right out of the smelters. Rather than merge them up and then resplit them right there. If it was a farther journey to go, it would be easier just having one belt, but since this is such a short trip, 2 belts is plenty easy enough. So I'm gonna send those down to this level, I guess, and it's gonna come over here. So we're gonna have the 90 casings plug into here, and then we'll send the 60 down to here, and these are each going to make our aluminum sheets since each one outputs 30. We've got those clocked at 100%, and I'm just now realizing I actually need to add one more floor for a smelter. The reason I built this right here is it's on top of a copper node. So I'm going to go ahead and do that, and I'm also going to finish up all of the belt work and the power. I'm going to obviously delete all of this, and then the next and final step will be to get it all turned on. And before I do that, I will show off how the train is going to work. So let me do that real quick, and I'll be right back. Let me explain the last couple things before we get this thing turned on. We've got 3 of the bauxite nodes right here. So we're going to have a 600 line from the pure node, and then the normal, I think this is the normal. Yeah, the normal and the impure are going to get merged together, and this is going to be a 450 line right here. And let me show you what's going on at the far bauxite nodes. Okay, so now we're over at the far nodes, which are all the way down here, the far edge of the swamp. I've already got the train running just because that's just easiest in my opinion. So we've got a normal node and an impure node. So those are both just getting fed right into the bottom of the train station. So let me show you what's going on down here. So those are just getting merged up. So we're getting 450 into here, and then these are feeding into the train station. So if you're new to trains, there's hundreds of fantastic videos out there on all the intricacies, but the one tip I have for throughput is definitely use a storage buffer. Since 450 is going in here using 2 Mark V belts, it'll only pause for 15 seconds when the train is docking, but this will make up for that lost time essentially. So that's the simple setup out here. Let me show you what it looks like on the other end. So here's our train stations right next to the aluminum factory. The bottom one is for the bauxite drop-off. The top one is for the finished goods to head on back to the storage. So let me show you inside and what we did here. So since trains and other vehicles are just going to drop off all of their goods, and I want a consistent 450 a minute instead, this is how I achieve it. I have 2 splitters and a merger coming in from the train station. So these are the 2 lifts that are bringing in the initial bauxite. Those are going into the storage container. We're going to then use the splitter to split off 60, and since this will be a completely full built because this is coming out of the storage container and it's just getting all dropped off at once, we'll get the full 60 and we're going to send 30 along, and then we're going to loop 30 back into the storage container. So that way we've basically just taken 30 out of the 480 line, leaving us with our 450. And we'll send that 450 on out over to the factory. Let me show you what we did there. Okay, so this is the simple load balancing we did to achieve getting 300 into each one of the sets of refineries. So since we have 1 pure node in this whole thing, it's just 600, split it, 300, 300. These 2 lines are each 450 a minute. So if we split 450 3 ways, that's 150 on each of these builds. So all we had to do is split each one of these 3 ways and put 2 into a merger. So we basically took 2 450 lines and created 3 300 lines, and we sent those on into the refineries. We're finally at the last step, getting to turn it on. So I am going to do this in 2 stages. So I don't want things to completely back up with the water because that means things come to a screeching halt, but I do want the alumina solution to more or less back up. So I've disconnected the petroleum coke, so these refineries won't get turned on until I connect this, letting this back up a little, since these refineries need 150 water, but these water extractors are only putting out 90 to feed 2 of them. It's going to take a couple cycles and they'll be stopping and starting, but once they get backed up, I'll connect this and we'll watch the entire thing come to life. So let's go flip that switch. Now that all the refineries are backed up, we can go ahead and connect the petroleum coke and watch everything come to life. And there we go. We've got 60 aluminum casing and 60 aluminum sheets headed to storage. With the excess 1350 aluminum ingots headed to the sinks already, this is mission complete. So the easiest way to be able to tell that everything is working is being able to look at my power graph and see that the consumption is a nice rock steady line. So that means all the machines, not just here, but across the world, are all running at 100%. So the next project is going to be radio control units, and I'm going to use the quartz from over there, and I believe the copper that's somewhere over here, and use the same train station to get those transported back to storage. So look forward to that, and thanks for watching.